Hello guys, so welcome to your channel which is Sci Engineers. From today onwards we are going to start with the preparation part for your MHCET 2018. For the guys who are new to the channel, we would like to recommend them the earlier videos which we have uploaded for the MHCET section for the last year. So just like the last year, this year also we are going to be uploading videos for the preparation part for your MHCET mathematics section. So if you want to get the regular updates of those videos, you need to just subscribe to our channel, hit the bell icon to never miss a notification of the videos which we are uploading. Do hit the like button and do share our videos so that it helps us make more videos for you guys. Also share it with your friends so that it helps them also in their preparation. So in today's section we are going to take up a topic which is related to your 11th standard, which is functions. So in this we are going to be discussing what basically functions are, with the different types of function, and we are going to see some of the questions which are going to be based on this. So to define a function, we have to understand these notations. That is, your f is defined over two sets, that is a to b. That means that all the values which are present in a, or all the elements which are present in a, will be uniquely defined by some element, or will be associated uniquely with an element which is going to be present in b. If this case arises, then this thing is called as a function, wherein your a is called as the domain of the function, the b is called as the codomain of the function, and the range is going to be the subset of b. Now to understand the range is nothing but the values which your functions is going to be giving you. To understand what do you mean by domain, domain is nothing but all the values which we can substitute in the function and which are going to be valid for that particular case. The next thing which we need to understand is the definition of even and odd function. So even functions are those functions which satisfy this equation, that is your f of minus x will be equal to f of x, then it is called as even function. If my f of minus x equals minus f of x, then it is called as your odd function. So one thing peculiar about this odd function is, if you are using the equation that is f of minus x equals minus f of x, what you will be getting is f of minus x plus f of x will be equal to 0. So if you substitute x equals 0 in this, what you will be getting is f of minus 0 plus f of 0 is equal to 0, but f of minus 0 is nothing but f of 0, so you will be getting this thing as twice of f of 0, which basically means that f of 0 is 0. So this is one of the specifications, or one of the defining point in your odd functions, wherein you will always have at the odd function at the point of 0 for an odd function the value of the function to be 0. So the next definition which we are going to see is for your periodic function, which states that your f of x plus capital T will be equal to f of x. Now what this indicates is that your function f of x plus t is equal to f of x, means the value of the function is repeating after every alternative time. So that alternating time is basically this t, which is also called as your time period. So after every t, your function is going to be repeating itself. So that is why it is called as your periodic function. The next type of function which you are going to see is called as your composite function. So composite functions are nothing but functions of a function. So it can be denoted by this, that is FOG. That means basically it's function of g of x. So in this type of functions, or in this type of composite function, what you have to basically do is, if you have the definition of your f of x, so you will be having the definition of f of x, that is basically the equation of f of x. You will also be having your equation of g of x. So if they are asking you FOG, that is function of g of x, that is f of g of x. So what you have to do is simply you have to substitute wherever x is there in your f of x with g of x. If either way it is given, that is GOF, that is your g function of f of x, then that in that case what you have to do is, wherever x is there in your g of x, you have to substitute your f of x. So we'll be seeing this in the problem section, wherein you will be able to understand what basically this part is. So these are some special types of function, which is basically, the first one is your modulus function. So that is y modulus x, which is defined as, it is defined as negative x for x less than 0, and it is defined as x for x greater than 0. So by modulus you mean you are always going to be getting a positive value whenever you are substituting any value inside the modulus sign. Now the graph for that you can see is in this V shape. So you have to basically remember this particular definition, that is, for the negative values of your x, it's going to be giving you the value as minus x to make it positive basically. For positive values of x, it's going to be giving you x. The next function which you are going to see is called as your greatest integer function, which is also called as your step function, and it is denoted by your square bracket x. So in this, basically what you have to remember is, for any values which is between two integers, it's going to be taking the least integer of that range. So basically if you are having like 0 to 1, it's going to be having the value as 0. For the values between 1 and 2, it's going to be taking the value as 1, and so on. So that is why it is called as your step function. There is also a ceiling function which basically gives you the highest value. That is, if you are having the range of 0 to 1, it's going to give you the value as 1. For the value 1 to 2, it's going to give the value as 2. So it's basically giving you the upper value in that particular range. Next one is your rational functions. So rational functions are nothing but the division of the polynomial functions. So polynomial functions are nothing but those functions wherein you will be having the degrees of x, basically, which are going to be integers, positive integers. So those are called as your polynomial function. If you are having the ratio of the polynomial function, then that is called as your rational function. So whenever you are understanding rational functions, the domain of the rational function, because if you can recollect, for polynomial function, the domain is basically the entire real number axis. For the domain of your rational function, it's going to be the entire real number axis, but you will be neglecting the values for which your q of x is going to be 0. So basically you have to find the roots of your denominator polynomial, and you have to remove those values from the range, that is from the domain R, to get the domain for this particular rational function. So we'll be seeing some problems which are going to be based on this particular section. So let's have a look at these set of problems. So the question is, we have to find the range for this particular function definition. So you have to once again understand what this basically is. It's stating that the set A, which is basically from where we are going to be taking the values of x. So the values of x which we can take or substitute inside the function are going to be between 0 and 1. The square bracket indicates that we can take the value, the end values, and it's going to be between 0 and 1. And it is going to be pointing towards the real domain or the real number axis. So basically that R is indication of your range of values or the values which we can have. That's the real number value. Now the function is defined in this way, that is x cube minus x square plus 4x plus 2 sine inverse x. Now in this part is nothing but a polynomial, so obviously it's going to be having all the possible values which you can get. For the sine inverse x, you can have only the values which are going to be between pi by 2 and minus pi by 2, because we are considering only the principal values for this. Now since the values of your x is going to be between 0 and 1, what you have to simply do is you need to just simply substitute the value inside this particular function. So the lowest value which you are having is 0. So if you are going to be substituting that value, you will be getting this as 0 minus 0, and the entire thing basically becomes a 0. So the lower limit is going to be equal to 0. So the lower limit is equal to 0 and it's going to be equal to the 0 value. So we have the square bracket for that. We have to find the upper value or the upper end for this. So the upper end is given by this, wherein you will be substituting x is equal to 1. Once you are getting the value as 1 inside this, what you are seeing that this becomes basically 1 minus 1, which is 0. This becomes a 4, which is into 1, plus 2 sine inverse 1. Now sine inverse 1, we have to find the principal value, which is going to be pi by 2. So that becomes basically a pi, that is 4 plus pi. So you can see that that option is nothing but your B option. Coming to the next one, you have to find the domain of this particular function. So domain is nothing but the values which we can substitute inside this function, the values of x which we can have. So let us try to understand the function. So function is given as a log x minus 1 to the base of 2x minus 1. So let's rewrite it as log of x minus 1 taking the natural log, or you can take the log to the base 10 divided by log of 2x minus 1, which is basically the property of your log. You're changing the base, so you'll be having this particular formula. So now for log, you have to understand that log of a negative number for now is not defined for you guys. When you're going for the higher studies, you will be getting the definition of negative logs also. But for now, for our convenience, we are not going to be considering the negative logs. So log of a negative number is basically not defined. So what we have to see is, we have to see that the value inside the log is not going to be a negative number, and also it should not be equal to 0. So from the above part, what you're getting is that x minus 1, basically if I substitute x equals 1 in that, you'll be getting the value of this as 0. So that is why we have to eliminate that thing. So x minus 1 first of all should not be equal to 0, or basically we have to write it as it should be greater than 0. From this you have to see that your 2x minus 1 should also be not equal to the value which is going to be equal to 0. So that is why your 2x minus 1 should be greater than the value which is 0. So from this you're getting x should be greater than. So next thing which we have to understand is that the denominator part should also be not equal to 0, because then the function will be going to infinity, or it's basically not going to be defined for that particular value. So for that, what you have to understand is that the log of 1 basically is equal to 0. So that is why if you are substituting, the 2x minus 1 should not be equal to 1. So that means you're getting it as 2x not equal to 2, or basically x is not equal to 2. Sorry, x is not equal to 1. So you're getting this particular condition. Now considering these two conditions, that is, they should basically be considered together. You are having this as x greater than 1 and this is x greater than half. So obviously from these two we'll be considering this. So we'll be having only the consideration of x greater than 1, and which is obviously satisfying this particular condition, which is x not equal to 1. So the only option which is available, that is, it should not be equal to 1 and it should be greater than 1. The upper limit is not defined for this, so basically it will be going towards the infinity value. So the value is basically going to be between 1 and infinity, neither of which are going to be considered. So you will be having the domain or the answer for this particular question as the A part, which is 1 to infinity. We are having circular bracket, that means the values are not going to be considered while considering the domain or while considering the x value for this function. Considering the next question, which is your f of x equals half minus tan pi x by 2 for the domain which is minus 1 to 1. So the x value which you are going to have is minus 1 to 1. G of x is defined as this thing, that is root of 3 plus 4x minus 4x square. Now for that, the domain is not given. They are asking us what is going to be the domain for f plus g, that is the addition of these two functions. So when you are having addition of two functions, the domain is basically going to be given by this relationship, that is the domain for the first one intersection the domain for the second one. The domain for the first one has already been given, the second one is not given to us. Now when you are having a root of a polynomial function, basically you have to see that the root of a negative value should not exist, because we do not define the root of a negative value because it does not come inside the real number axis or in the real domain. So we have to check those values of x for which this function is going to be going to negative. So considering that value, that is 3 plus 4x minus 4x square, we require that this particular value should be greater than 0. Now considering it in the normal format, that is the x square to be in the first position. So let us consider this as 4x square minus 4x minus 3. Now since we are multiplying throughout by minus 1 basically in this, the sign, this greater than sign will change to less than sign. Now in this we can have the value as 0 also, so we are considering the equal to part also in so this. Finding the roots of the equation and then simplifying it, you are getting the factors as x minus 3 by 2 and x plus 1 by 2. Now this product has to be less than 0, that is it should be negative value. So for that to be negative, you have to consider that when you are having product of two numbers, the product will be negative only when one of the value is going to be negative. So you have to consider two cases. The first case wherein you will be having this value as less than 0 and the other value as greater than 0. That means this is going to be the negative one and this is going to be the positive. So the case 1 is going to be for x minus 3 by 2 going to be less than 0 or the negative. So that is basically x less than 3 by 2, and from this should be a positive number. If this is negative, this has to be positive. That means that x should be greater than minus half. You are getting the value as x as less than 3 by 2 and x as greater than minus half. So basically my x value is going to be lying between 3 by 2 and minus half, or basically it can be equal to it also. Considering the second case, the case 2 is going to be when this is going to be positive and this is going to be negative. So you will be having the opposite version of this, that is x greater than equal to 3 by 2 and x is less than equal to minus 1 by 2. But you can see from this they are basically contradicting each other. Your x is greater than 3 by 2 and x is also less than minus 1 by 2, which is not possible. So that is why we will ignore this case and only this case is going to be feasible. So this basically is going to be the domain of just g of x. Now since they are asking us domain of f plus g, and f plus g means its addition, so it's going to be the intersection of the domain of your f and intersection of the with the intersection is basically going to be with the domain of g. So you have the domain of g, which is minus half x to 3 by 2, and for this it's minus 1 to 1. So the intersection part between this is going to be the minus half to 1. So that's going to be this particular value. Since you can see that 1 is not equal to, you are having the circular bracket and it is equal to half minus half, so you will be having the square bracket. So it's your C option. So let us consider these questions now. We are having f of 0 is equal to 1, f of 1 is 5 and f of 2 is 11. You have to find the equation of the polynomial with degree. Now since they are asking us to find the polynomial with degree 2, what we can assume is f of x is equal to ax square plus bx plus c. Now you have to simply substitute the value of x. So first x value is given as 0 and the value for that is given, that function is given as 1. So substituting x as 0, you will be getting 1 is equal to, this becomes 0, this becomes 0. So basically you are getting the value of c as 1. So replacing that, now next is you are given that f of 1 is 5. So you will be giving this as 5 is equal to, substituting x equals 1 in that. So you will be getting a plus b plus 1. So that becomes a plus b is 4. The next one, which is f of 2 is 11. So we'll be getting the equation as 11 is equal to, this becomes 4a plus 2b plus 1. So this becomes basically equals to 10. So solving this simultaneously, so you're getting the value of a and b as 1 and 3. So substituting in this, so a is 1, b is 3. So you're getting x square plus 3x plus 1 basically equal to 0. So the equation is going to be equal to this particular. There's one more way to find the equation. It's basically by trial and error method. They have been giving you the value of your functions for different values of x. So your f of 0 is equal to 1. So you'll be simply substituting in each of them the value. You'll be getting for this also 1, this also 1, this also 1. So basically all of these three criteria can be possible, or also the fourth criteria, which is basically the generalized one. The next one is f of 1 is equal to 5. If you are substituting in this the value of x as 1, you will be getting this as 2, which is not satisfying this. So basically you then ignore this one. If you are substituting 1 in this, you will be getting this as 1 minus 2 plus 1, which basically again does not satisfy the equation. So you will be ignoring that also. So only the next thing is basically then you have to check for this also 2. You will be getting this as a 4 plus 3 into 2, which is 6, which is 10, plus 1, which is 11. But there is a possibility that because of this condition you cannot actually get the answer for this. So if you might have had another polynomial which would have been given over there, then in that case this particular technique would have worked. But since this is a generalized form, none of this, it basically does not tell you what basically the polynomial is. So it is better you try to find the values of a, b, c in that. So while finding the inverse of a function, basically what you have to do is you have to just replace the f of x as y. So you'll be getting this y is equal to 2x minus 1 upon x plus 5, and you have to then simplify according to like x is equal to form. So cross multiplying, you will be getting this as xy plus 5y is equal to 2x minus 1, taking the x terms together and all the terms on the other side. So the 2x goes this side, so we'll be getting the x common. This becomes y minus 2 is equal to minus 1 minus 5y. You'll be taking this down, so you'll be having this as minus 1. Let's take that minus common. So we'll be having a minus common, which is 1 plus 5y divided by y minus 2. From this also let us take the minus common, so that becomes a 2 minus y. So the minus gets cancelled. You are having this as x is equal to 1 plus 5y upon 2 minus y. So for this, what basically you have to do is, this becomes your inverse, that is inverse of x is defined as you have to replace your y by x. So you will be having this as 1 plus 5x upon a 2 minus x. So this is the simplest way to find the inverse. So going to the last question for this particular video. So you are having a f of x which is defined as this. You have to find f of this 19 times of x is, you have to find what is going to be the value. So for this, what you need to do is you need to just find the initial, what is going to be the function of function. So let us find what is going to be f of f. So what you have to simply do is, in this x, wherever x is present, you have to substitute the function itself in it. So f of f is going to be equal to your, wherever x is there, you are going to substitute x upon 1 minus x. So that becomes x upon x minus 1 divided by, here x is present, so that becomes x upon x minus 1 minus 1. Simplifying the denominator part, you will be having this as x minus x, this becomes plus 1, this whole thing divided by x minus 1. So the x minus 1 gets cancelled out, x gets cancelled out, you are remaining with only x. Now the third f, you are getting back the equation, that is x upon x minus 1. So this is going to be changing, so it is going to be going back and forth between x and x upon x minus 1. Then you have to see what is going to happen at the 19th time. So since 19 is an odd number, and for every even you are going to get the value as x, for every odd you are getting the value as this. You are getting the 19th time, so it's going to be the odd part, that is going to be x upon x minus 1. So that is why the correct option is going to be. So these are some of the sums which are related to your functions. If you want to get more videos on this, do write in the comment section. Do write in the comment section what more videos you would like us to make on. We'll be continuing to make more videos on the MHCET preparation for the mathematics section. So do share, do like, and do comment in the comment section. We are associated with the Samartha Vidya classes, which is group tuitions for the engineering and science students. We have been helping students for their preparation for their engineering levels and also for their entrances. So if you want to know about us, you can just do so by emailing us at samarthavidya@gmail.com. You can visit our website, which is samarthavidya.com. The link for the Facebook page, the link for the website, and also our email address is given in the description below. So hit the bell icon, hit the subscribe button if you're new to the channel. So keep learning, keep watching, and happy learning. Bye.